Hello guys, myself Vilakya Madivanan and my team members are Rushina Shukla and Collins Anobin. Our project is to design and build an infrastructure wireless network for a three-story building. Increasingly, the needs of modern homes and workspaces are for greater and more versatile internet coverage than just having a single PC or a group of PCs wired up to a router with Ethernet cables. Wireless networks enable multiple devices to use the same internet connection remotely as well as share files and other resources. The main advantage of a wireless network over a wired one is that users can move around freely within the area of the network with their laptops, handheld devices, etc. And hence they get an uninterrupted internet connection. Now me and my friends are going to explain the agenda given here. The aim of a project is to design, build, configure, and to test an infrastructure wireless network for a three-story building, and it also controls and monitors every possible device on the network. We have implemented this project in the Cisco Packet Tracer software, where we have used the wireless components such as routers, firewall, switches, access point, etc. Now, I'm going to give a brief description about a router. So a router is a device which allows communication between the local area network and other connected devices with the internet. It is designed to receive, analyze, and move incoming packets to other network. It is also used to convert the packets to another network interface, drop them, and perform other actions relating to a network. The main purpose of a router is to connect multiple networks and forward packets destined either for its own network or other networks. A router is considered a layer 3 device because it is primarily forwarding decision which is based on the information in the layer 3 IP packet, specifically the destination IP address. There are many types of routers such as core routers, edge routers, distribution router, and wireless router. The firewall is a security device that monitors incoming and outgoing network traffic and takes decisions of blocking and allowing certain data traffic based on the set of security rules. It is used to prevent the information to and from unauthorized private networks. Firewall is a software that stands between a computer or network and the internet. So connecting a computer directly to the global network is leaving your computer or allowing outsiders for free access to your own system. Any request will pass through to vulnerable systems, allowing unscrupulous third parties to exploit your own computers for their own gain. So a firewall blocks these unauthorized requests, passing only the designated traffic. The existing firewall types are packet filtering, circuit level gateway implementation, and proxy firewall. You can configure a firewall to disallow access to certain websites or services to prevent the system from accessing non-work resources while on the clock. Typically, a firewall allows traffic from common programs such as email or web browsers while discarding most incoming requests. A switch is a networking hardware that connects devices on a computer network by using packet switching to receive and forward the data to the destination device. A switch is a multi-port network bridge that uses MAC addresses to forward the data to the data link layer, which is the layer 2 of the OSI model. And some switches also forward the data at the network layer, which is the layer 3, by additionally incorporating routing functionality. The purpose of using a switch in a network is it uses the network connection point for hosts at the edge of a network. In the hierarchy internetworking model and similar network architectures, switches are used deeper in the network to provide connections between the switches at the edge. Network switches can be deployed in many ways such as edge or access switch, aggregation or distribution switch, and core switches. The types of networking switches are virtual switches, routing switches, managed switch, unmanaged switch, and smart switches. And the rest of the PPT slides will be explained by my friends. Thank you.
The multi-layer switch is a network device that has the ability to operate at higher levels of the OSI model. Unlike the traditional data link switch, a multi-layer switch can perform the functions of a switch as well as that of a router at an incredibly fast speed. A switch traditionally inspects frames, while a multi-layer switch inspects deeper into the protocol description unit, just like a router. Then also the access point. Now the wireless access point is also a device that creates a wireless local area network. Usually in an office or in a building, an access point connects to a wired router, switch, or a hub using an Ethernet cable and projects a Wi-Fi signal to a designated area. So we are using the access point so that our clients can be able to hook onto the internet using to access the internet. Then also our block diagram. In our block diagram, we have our ISP, which is our internet service provider that we are getting network from. And then it comes to our firewall device. And our firewall, what our firewall is doing over here is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. A firewall typically establishes a barrier between a trusted internal network and untrusted external network, which is the internet we are receiving from the ISP, because we don't trust it because it's an external, so anybody can hack through it. So our firewall is there to monitor and filter all unwanted data from coming into our network, which is people trying to hack through it. Then also in our simulation, we are using the Cisco packet tracer, and the Cisco packet tracer is a cross platform tool designed by Cisco that allows users to create network topologies and imitate modern computer networks. The software allows users to simulate configuration of Cisco routers and switches using a simulated command line interface. So the packet tracer makes use of Cisco devices and then user interfaces, so it allows users to be able to add, remove, and simulate the network configuration. So we are using the Cisco packet tracer to simulate our network and then get the solution or get the accurately how the network is going to work when implemented on the grounds or on the site. Then our project design shows the design of our network, the network topologies, the devices used, which are the router, the firewall, the multi-layer switch, the main switch, the access point, and then the client, how they receive their signals. That is basically what the project design talks about.
I'm Rushina Shukla and I'm going to talk about configuration of components. So we have configured our firewall, VLANs for switches, trunk for switches, and access point. So let's start with Cisco ASA 5505 configuration of firewall. So uh, we have done it in the 6 steps. So first we have configured the internal interface of VLAN, and the next we have configured the external interface VLAN which is connected to the internet, and next we have assigned the Ethernet 0 bar 0 to VLAN 2, and we have enabled the REST interfaces with no shut, and lastly we have configured the PAT on the outside interface and also configured the default router, which is connected towards the internet service provider. So the next one is configuring the virtual LAN, that is a logical grouping of devices in the same broadcast domain. So VLANs are configured on the switches by placing some interfaces into a broadcast domain and some interfaces into another on a Ethernet LAN. So after configuration of VLAN, we have configured the port VLAN ID so that we can know which VLAN to use for the traffic entering that switch port, as we are using three switches. So by configuring the port as an access port on the particular VLAN, it automatically takes traffic coming in on that port. Other switches require this to be configured in or two places. The next is trunk configuration, which is a single channel allows multiple entities at one end to correspond with the other entity at the another end. So it acts as a link that carries many signals at the same time and create more efficient network. So it can be configured on a switch. Uh, so firstly, uh, it is assigned to carry traffic for all VLANs that are accessible by a specific switch, and an Ethernet interface can either function as a trunk port or an access port, but not both at the same time. So firstly, we will enable configuration mode on the terminal, and we will assign the access port mode on the trunk, and we will assign access VLAN ID on the switch, and we will give the interfaces and interface ID trunk, and we will start the running config. And lastly, we have configured the access point by giving the service set identifiers, that is SSID, which is a default name given to a network by the manufacturer, so that we can distinguish our own network from the other networks in the neighborhood. So we have given our network name and also the VEP, which is for the security purpose, and also given the pre-shared key as a password. So that is how we did our configuration part. So let's talk about the working principle. Uh, so the wireless LANs, we have used the ad hoc topology, which is also called peer-to-peer network, where each PC equipped with a wireless adapter broadcast and receive data to and from the transceiver, also the access point within 300 feet. And we have used multiple access point for the seamless network, so that user can roam freely without any interruption in the network. And in this infrastructure topology, each PC sends data to and receives data from the access point, which is mounted on a wall. While all wireless LANs work on this common principle, the speed at which they transmit data and frequencies they use differ depending on which standard they follow. Our project, we have used the standard of IEEE 802.11 and IEEE 802.11b, and all the adapters on the network must adhere to this standard. And all the standards call for a use call segment of the 2.4 GHz radio bandwidth for sending data. We have also used multi-layer switches and multiple access points so that user will not face any interruptions or degradation of signal. When the signal degrades, the access point will do the seamless handover to another access point having stronger signal in the same range, which are connected in the same Wi-Fi, and that will use the same SSID, same security domain, same passphrase, and same DHCP server but different channels. And also we have used the firewall for better security purpose. So this is our testing part. We have tried to ping from the user equipment from flow 1 to our firewall security, which is, as we can see, is successful. And similarly, we have
tried to ping the flow to user equipments to the firewall, which is also very successful. And same for the floor 3, by which we can get to know that our network is not facing any difficulty, and it's also clearing the security issues in our Wi-Fi. Lastly, in the conclusion, wireless networks are globally something that people can expect as technology advances, and wireless networks have a lot of benefits and can make the world a lot more efficient. And by this project, our aim is to provide enhance and uninterrupted connectivity to the users, and also the user can roam freely, having seamless network, and we can transfer our network from between each devices. So the issues with security regarding access to the personal information or the negative impact that it may seem to have on society are the few things that are holding back the progress that wireless technology could be making. With more research and experiments conducted, the problem associated with wireless communication can be reduced and make it more significant part of the world. So wireless technology will be very important in the near future, where the need for wire connecting individual devices seem to be coming an end. Thank you for